Hello. Today we are going to look at stem plots, or you may see them called stem and leaf plots. All right. Stem and leaf plots are better with small to medium data. Okay, and we're going to look at how we would do that. General. Let's say that I wanted to plot the scores of block A. Okay, a stem and leaf is just how it sounds. You have a stem and a leaf. So these are all two-digit numbers, and I notice my grades are all in the 70s, 80s, and 90s. So I'm going to put a 9 for 90s, an 8 for 80s, and a 7 for 70s. And then I'll look at these and I'll go put all my numbers in. Now for me, I might want to circle all my 70s first. So I just have 2. So 5 and 8. So I would read this 75, 78. Now to make sure you can read it, you always include a key. So my key is 7/5 means 75. So you do the same thing with your 8s. Now I'm going to underline my 8. So there's an 8, an 8, an 8, an 8. So I have a 6 and 3 8s. And you always put them in order. And the only thing left are 9s, and I've got a 0, 1, 2, 3, 8. Okay, so that's an easy way to show a distribution. We have a stem and the leaves, and this shortens our work. Instead of having to write all these out, I can say 90, 91, 92, 93, 98, and 86, 88, 88, 88, 75, and 78. This is kind of nice because it shows me a few things. Like I can definitely see that I had more 8s than anything else in the 80s. 88 was the score I had the most. I can also see that I had more 9s than anything else and only 2 in the 70s. Sometimes we might want to compare more than one thing. What if I wanted to compare block A to block B? Well, I can set that up as well. I can keep my 9, 8, and 7 because all my grades are in the 90s, 80s, or 70s. So I'll keep those. But what I'll do, that's my stem. I'll put a leaf on both sides. So this would be block A. This would be block B. So of course, block A is 90. And I've already done the work, so I can do this. Now you're going to count out. So it's going to go 0, 1, 2, 3, 8. You read out from your stem. So it's going to be 6, 8, 8, 8, and 50, and the 8. Now I'll put block B on there. I'll do those in a different color so they show. So now I'm going to look at B. Notice I don't have any 70s, so let me look at the 80s. There's my 80s, so it would be 5, 6, 6, 7, 8. And of course, my 90s, I have 1, 1. So those are those. And then 2, 2. They must go in order. 3, 4. Okay, so this might be a nice way that I could compare block A to block B and see what's going on with those, right? A split stem, sometimes these numbers stick out really far. So rather than keep going and making my paper really, really long, I'll write a 9 in there twice. Now, if you do it for the 9s, oh, we forgot our key over here, key. You know, I would say 8/5 means 85. When you tell someone what that means, that reminds them that this is the 10ths place and this is the 1s place. So let's say I don't have enough room to just make my leaf be that long. I can do 9, 9, 8, 8, 7, 7. So I'm going to do block A again. What we need to do is decide how many numbers would be in the top and bottom. They need to be the same. So I would choose to do 5 digits here and 5 digits here. So this one, I would do 0, 1, 2, 3, and 4. 1, 2, 3, 4, 5, right? And then I could do 5, 6, 7, 8, and 9 here. Okay, so you need to make up your mind what numbers are going to go where. Like I could do 3 9s if I had too much data. But anything that's a 0, 1, 2, 3, 4, I'll write there. So it's 0, 1, 2, 3. Then anything greater than 4, well, I know that I had what was greater than 4 here. It was an 8. So see, instead of just going all the way out, I'm coming down. And that's if I have more data points. The 8, again, I'm going to have 0 through 4 would go here. I don't have any of those. So I'll have 6, 8, 8, 8. Again, with 70, I would have 0 through 4. There were none of those. So I have a 58 here. And of course, we would have a key. Many times when you do these, you might want to use a stem and leaf for decimals and things like that. What's a great thing about this? It shows all data points. Okay, what is this? By now you're used to that answer. It is a graphical summary. Right, just like the histogram, just like the dot plot. What does it do? It shows a picture of the distribution. How does it do it? Okay, so we would say the numbers are divided into leaves and stems. How is it used? It's like a histogram, often used when technology is not available. Okay, so we're more than likely we would use technology, but if technology is not available or we just want a real quick way to compare numbers, we can use this, right? You know, you got quite a few numbers, you don't have any technology, so this makes a great deal because I can look at it, I can see what occurs the most, I can kind of see a shape, I can compare two classes, I can break it down smaller if I have too many numbers sticking out, okay? So we're going to look at a few important features of a numerical distribution. We want to pay attention to describing the shape of the distribution. The typical value or center, right? We want to know the center of the distribution and the variability, which is the spread or the width. Right? How wide is my graph and where's the center? Kind of think about that. These are really important features of our graph. Where's the center and how wide is it? How spread out are my values? Okay. First of all, a new word for you. Is the distribution symmetric or skewed? Symmetric means the left and right are relatively the same. So this would be very symmetric if you put a Line down the middle, it looks the same on both sides. So this is symmetric. But if we look at this next one, the data are skewed. If I were to draw a curve over this, I would have it would be way up, and then this tail would be very long, or this one. Here we have a tail. The tail is on the right. Left, sorry. Tail's on the left. That means it is skewed left. Okay, when we say it's skewed, the skew part is the where the tail is. Here's a tail on the right. So we would say this one is skewed right. Okay, so just look at those. Symmetrical, skewed right. We've got the short ones, the tail coming out to the right. Skewed left, we've got a tail on the left. Okay, if you want to think about this one, you're going to see a long tail. And if you think about this one, it's going to be a long tail on the left. Okay, so that's one way that you want to describe the shape of your distribution, that it's either symmetrical or it is skewed, it has a tail. Another thing we want to describe is how many mounds appear, or how many hills, if you will. Okay, unimodal has one hill, right? Bimodal has two peaks or two hills. Multimodal would be looking like this, okay, a bunch of hills. So mounds can have different heights. Bimodal and multimodal data may indicate existence of different groups within the data. In this case, it may be preferable to separate the data into two groups and provide separate graphs for each group. Examples would be men and women's heights, afternoon and evening sales at a restaurant. If we start to get this, we want to look and say, hey, do I need to divide this data up? Do I have too much stuff in there? Right? So very important that we know our vocab. You need to be able to describe something as skewed or symmetrical, and then unimodal, bimodal, or multimodal. What shape would you expect to see in a histogram of the following data sets? GPA, SAT scores, last digit of the social security numbers, income of USA residents, right? So these are all things that we can create a histogram for, and we want to look at our histogram and say, is it unimodal, bimodal, or multimodal? Again, if it's multimodal or even bimodal, do we need to divide it up into smaller groups? Third thing we want to look at is outliers. Outliers are unusually large or small values. They don't fit the pattern of the rest of the data. They're not precisely defined. They're subject to opinion sometimes. When you see extremely large or small values, report the values. Realize they could be sources of error. Genuine outliers are unusually interesting data values. So if everything is clustered here, and then I look over there, I see an outlier. And it may be something of interest to me. So it could be an error, it could be interesting, right? If I were looking at, I don't know, if I were looking at your grades and everybody was over there in the 75 area, and then you're over here with a 100, I want to know why. How did you do it, right? It's interesting. All right, couple more little things. Center, is there a most common value? The histograms for Division III first-year women's soccer players and women and men's soccer players are given below. So the number of goals they made. If we look at this, for the women, we have a center right here. And for the men, we have a center right here. For the women, it's 16 goals, the men is 13 goals. It would seem that a typical male soccer player scores fewer goals in a season than a typical female soccer player. Okay, so we want to look at the center, what's going on there. Variability, the amount of variation. That's the horizontal spread. If all data values are similar, we have a narrow graph. If data values are different, we have a wider graph. So for the women, you know, we're narrow for most of it, 9 to 24, right? We look narrow with this outlier over here. The men's graph looks a little bit wider, right? Of course, part of this is due to the way the histogram is, but this is a wider graph. All right, describing numerical distributions. Remember, we always want to look at the shape. Is it symmetric, skewed left, skewed right? And then also how many modes, unimodal, bimodal, center, what's a typical value, could be the average, and variability. How wide is it? So in the future, if you're asked to describe a graph for me, I would want to make sure that you said this is symmetric with a center of 85 with a horizontal spread of 22 or whatever that comes out to be. These are definitely 3 things that you want to include anytime that you are asked to verbally describe a graph. All right, have a great day.